much. It's really a pleasure for me to have these possibilities to speak to all of you all together. I'm very happy to be here with you today. Good afternoon. After lunch is not going to be easy. I hope I'm going to entertain a little bit you with a few slides. So let's go to the agenda. A bit of warm-up. Warm-up is what about AMD and high-performance computing, a little bit of history, what we did in the past. I want to talk with you about the present, so a little bit of Opteron 6300 series, so the product we have right now in the market. And then the focus of the presentation, that is going to be what we think is changing in the market and what we are doing as AMD to address better the challenges, generally speaking, of the server market and a little bit in particular also of the high-performance computing. Then, considering I'm a sales and not a technical person, I want to give you a couple of highlights on the product and then a question and answer. So let's start from AMD in the high-performance computing. And I tell you, there is a little bit also of emotion in me right now because there is Francesco Torricelli here with me, a former colleague of AMD. He was actually the maestro of the high-performance computing in AMD EMEA since a few years ago. I did grow with him. And now talking about the history of high-performance computing for AMD from 2003 to today with Francesco here, it's really a pleasure for me. So what we did, I think, so I don't have to tell you which kind of success we did achieve in high-performance computing from 2004, 5 to 2010. Everybody knows. You knows what we did well and what we did not well. Everybody will remember for sure what we call everybody Barcelona disaster. But we did also some good things during the last few years. And the main reason of those good things has been the completely new architecture we did bring into the market in 2003. I'm sure you all remember the challenge of AMD bringing to the market memory controller inside, hypertransport, and 64-bit. So these, and I'm repeating this because it's linked to the rest of the presentation. This has been key for our success in the following year during, inside the high-performance computing. What we have now is actually the evolution of this architecture, nothing dramatically different. So Opteron 6300 series is the product we are currently selling, not only in the high-performance computing, generally speaking in the server market, compared to what you call Interlagos. I'm sure you are aware what I'm talking about. So this is Abu Dhabi. The previous generation 6200 series was called Interlagos. What's new? Less power at the same frequency, same number of cores, same everything. Less power, a little bit of more performance. Even, again, if you consider same frequency, same number of core, Interlagos versus Abu Dhabi, there is a little bit of better performance and a better price. So actually, we did bring an evolution of the same architecture with a small improvement in performance, a bit more power efficiency, and an improvement in terms of price. That's what we have right now in the market. I'm quite sure many of you are familiar with these, I would say complicated, I don't know. So modular architecture. I said complicated because it's actually complicated from your side, from the developer side, from the user side, to be able to take advantage in the right way of this modular architecture, bulldozer architecture. So it's not easy because some of the parts are shared between two cores. Some of the parts are not shared, are independent, dedicated. So from the compiler point of view, developer point of view, is not something really easy, but we are having some good success. So I can tell you We are positioning this product in the high-performance computing in terms of price performance. That's the way we are currently selling. So someone of you during the break, during the coffee, came to me saying, hey, Roberto, how's it going? I don't see you so much present in the high-performance computing in this moment. What's going on in AMD? So the reality is that we are not really visible. Probably we are not like in 2005 on top of every high-performance computing magazine or website or list of the supercomputer, but we are still selling very well, silently, thanks to how we position ourselves in terms of price performance. Yes, probably the best performer in some of the applications you are using right now, if you are going for the best performance without taking care about the cost, is probably someone else, and maybe he's also here in the audience. I don't know if Intel is here, but they know. They don't need me to explain how to sell their products. But if you go and check from the price performance point of view, that's just an example. Just an example. I don't want to bore you with comparison. You can do that better than me, not on spec, on your own benchmark, with your own data, with your own cluster. Most of the time, when the customer is listening to AMD or to the vendor positioning the AMD proposition, we are still competitive in terms of price performance. I'm not saying we win every time, not. I'm saying we are competitive. And the message we bring to our customers, it's always take one moment and think about the AMD option. It's not buy AMD because we are the best. It's consider the option. Most of the time, from the price performance point of view, we are still very competitive. So here is just an example, as I mentioned to you. Yes, you understand. Come on, you are better than me. This is a comment from my side, because another interesting point is that this is a 2P comparison, but an advantage we have is that we leverage exactly the same architecture in a 4-socket machine. So our customers taught me. So the customers told me, hey, Roberto, by the way, if we go with the 4-socket architecture, we are able to save an additional amount of money on infrastructure, interconnection, InfiniBand, switch. And that's another advantage that sometimes in the high-performance computing tender, request for quotation, make the difference for us. So that's the present. So before talking about the future, and that's an old slide, don't lose your time on this slide. So I will drive you to understand the message. So before talking about the future, this is actually what we did in the past. And what is important in this slide is the split between the single socket part of the market and dual and quad and 8-socket part of the market. So AMD, like our competitor, since the last few years, has been focusing a lot of attention and research and development funds in the 2P, 4P, 8P socket generation. So that's what we did. Big socket architecture, big silicon, many cores, a lot of technology inside. Of course, the power consumption was going a little bit higher, but that's what we did in order to give you the best dual socket or quad socket performance. So now the slide I'm going to show you is without any information, because actually my colleagues told me that if I will present to you the NDA roadmap, they are actually ready to kill me outside here in Lugano. I will not go into my car. They will kill me here outside. But is part of the NDA roadmap without the names, without the codes. I go very quickly, but I want to show you something. So what is interesting is the ratio between the 2 and 4 socket part of the roadmap and the single socket part of the roadmap. So we are investing clearly in this, nice slide, very nice slide. where we are investing is here, is clearly here. You can show the ratio between before, okay, 2P and 8P and 4P, and single P was in the bottom, and we did start even later. And now where our focus is actually completely going into the direction of single socket, low power, high density. An additional step, okay, step by step, and then I go back to this previous slide. Let's go step by step all together. So this is again what we did in 2003, and so bringing Opteron 64-bit into the market has been extremely successful thanks to the direct connect architecture, so memory controller into the processor, hypertransport, thanks to multi-core that was actually coming a little bit later, 2005, and thanks to 64-bit. So here, my colleagues are saying enhanced programming model. The reality is that we did bring 64-bit on the processor in April 2003, but the reality is that you, the developer, the software ecosystem, the operating system, the compiler, everything landed into the market being ready to take advantage of this 64-bit architecture, unfortunately, a little bit later. So we had a couple of years, I remember very well, Francesco going around talking about 64-bit, but unfortunately we didn't have enough readiness from the software ecosystem point of view. So what's happening right now? What's happening now in AMD, where we think the market and where we think we have to go? So what's happening is that it's no more only x86. We are bringing into the market this heterogeneous system architecture. So heterogeneous system architectures means different cores, different architecture for different job. Will be mainly focused on low power and single P, will be x86, will be APU. I'm sure you are familiar with APU, Accelerated Processor Unit, is already available in notebooks or desktop right now. We will bring the APU technology into the server market very, very soon. Is part of the previous slide I didn't show you. ARM, I'm sure many of you are aware that we did, at the end of the last year, a license agreement with ARM in order to bring into the market ARM 64-bit, and the name is going to be Opteron, so it will be an Opteron based on ARM 64-bit multi-core. So another important step of this strategy is what we call AMD Freedom Fabric. So it's a technology that is coming from CE Micro. How many of you are familiar with CE Micro? Is a company, thank you, is a company that we acquired, we bought a few months ago before Christmas, probably even before Q4, and is a company that did what they sell. I tell you what they sell, and then I tell you why we bought them. What we sell, because now it's AMD, is a box with 64 server inside, very high density, 10 rack unit. I have a picture. I will show you the picture later. Full of stuff, full of technology, very, very, very interesting. But the secret of this 10 rack unit box is the fabric. And they actually didn't advertise too much this secret because it's their own intellectual property. And this was the main reason why AMD and many other vendors, I tell you, many other vendors were extremely interested in buying CE Micro. I don't know if we have been successful or not in buying them, not because we bought them, but because of the price. The price was going a little bit higher. It was like a tender. But from the technology point of view, so again, I'm a sales. I want to translate you this concept in something that even someone like me understand very well, is a kind of evolution of the hypertransport. So it's nothing related with hypertransport, two completely different technology. But if you think about the success of Opteron was strictly related with hypertransport. The way we did connect two processors on the motherboard, we did leverage hypertransport inside the silicon. We did leverage sometime hypertransport even between box. I remember very well a few technology that we did leverage to connect. InfiniBand also was available through hypertransport connection. So to connect different motherboard. So the same concept with a different technology. Of course, it's a proprietary technology coming from C Micron. And that's why, and that's what we need going into this direction, because if you think about what's the best and most efficient processor in terms of price, performance, and watt, is probably not a big Xeon, is probably not a big Opteron, is probably much more close to Atom or an AMD 3000 series. So that's something you can do by yourself, making some calculation. I said price, performance, and watt. The most efficient is probably going in that direction. The reason why it's not so common in high-performance computing or even in IT, standard IT, or in cloud, the internet service provider, is because the connection between the server in this moment is the problem. It's not, or on one side, it's not efficient. On the other side, you are smiling. If I'm saying something stupid, raise your hands. On the other side, there is the possibility that it's very efficient, but can be really expensive, okay? So in this case, we think we will have the possibility to have something at a reasonable cost, really efficient, to connect all together this very efficient single P processor. That's the strategy. So, sorry, I go back 1 second. Let me give you 1 point about the heterogeneous system architecture, because it's not theory, it's not an AMD brand, it's a foundation. Heterogeneous system architecture, it's a foundation. You can go to the website, unfortunately, I don't remember, I think it's .org, the website of the foundation. So if you are coming from a university, from a research center, if you are a developer, if you are interested in understanding this topic, please go to this website. It's full of very interesting information, actually more for you than for me. It's not a product. We don't sell anything. It's just developing something that will enable the developer, to take advantage of the different hardware architecture. ARM, APU, GPU, x86, so to write the software, compile, actually work with your application, being ready for heterogeneous architecture, not anymore only x86. This is really, let's say, marketing statement, but the era of x86 only for everybody and everything, it's done. That's what we think. So, and that's the same view, let's say, more in a practical way into the current market. So you are guys taking too much picture. I hope I will have a job next week. But no, I'm joking, this is public. So this is actually what we think is going to happen in terms of evolution. Of course, we will still have part of the traditional IT market that will stay on x86, for sure. Particularly if we think about what's happening right now with the virtualization with VMware. So I mean, it's so easy to deploy, to develop an IT standard ecosystem on x86 and VMware or whatever it is it's really easy. So they will not migrate to something different very quickly. But we think that there is a part of the market, high-performance computing, big data, and what we call internet service providers, so hosting or private and public cloud, that will have the possibility to choose between different technology with different level of density and different level of efficiency from the power consumption point of view. So that's the vision. And that's the marketing statement, what I told you before. So we are going into the direction of, for sure, much more density, x86 and ARM. x86 means x86 and APU. Of course, heterogeneous system compute architecture, and everything interconnected through Fabric. So Fabric is a technology, just to give you another beat, but you will find a lot of information about the AMD Freedom Fabric on the SeaMicro website or on the AMD website. So it's, again, an intellectual property. It's based on PCI Express, and there is an ASIC, so it's a silicon-based. There is a chip that drive these 3D interconnection between the server. Oh, finally, products. So I told you what we did in the past, what we have right now, what's the vision, but okay, so someone is still telling me, hey, by the way, Roberto, how are you going to survive until heterogeneous system architecture is going to be a reality? I mean, survive, I'm saying in the high-performance computing, because there are other very interesting markets where AMD is doing a very good job. But let's be honest between of us. So the volume of AMD in this moment in high-performance computing is good, but again, is not at the same level as we did in the past. So what's going on? This is actually something that in US in particularly is having good success. I'm quite sure you are familiar with Open Compute Platform. It's a project where AMD did work together with some of other partners. So the concept has been basically working together with some of the big data center in US, big customers, optimizing a motherboard, optimizing a platform from the power consumption and from the cost point of view. This was the main purpose of this project. So what happened is that we released some custom design. I said we, not we AMD. Open Compute Platform released some customized platform, motherboard. There are different designs right now into the market, and the concept, as I mentioned it to you, is really, let's say, removing components that are not strictly necessary, going down with the power consumption, going down with the price, and being able to be extremely competitive. This is actually having some good success in the internet service provider market, but also in the high-performance computing market, so I'm quite sure. And this is actually what is going to happen in the future. So it's a product that we have on the market right now, and there is still development happening, and this is what we think is going to be the future of open compute. So just a couple of words, because I've got some questions. This is the second product. The first product was the Open Compute. The second product is about graphic cards for computing. So with OpenCL, if you want to work a little bit on your code, we have some valid graphic card on shelf right now. And from the poor price performance competitive point of view, most of the time, again, I think we are still very competitive also in this market. So the last product I want to talk with you is a SeaMicro. So I mentioned it to you before, this technology is a 10 rack unit box. Inside you have 64 server, single socket, each one with an 8-core processor with 64 gigabyte, very, very interesting. Let me tell you just a couple of messages about this box. Very high density, really low power. So these 10 rack unit with 64 single socket server inside is gonna cost to you more or less 3.5 kilowatt. That's the average power consumption. So, and that's what the customer are telling us as a feedback. So one of the most interesting point of this product in your market, let's forget about telco companies, let's forget about internet service provider where this product is going very, very, very well. But in the high performance computing market, is becoming extremely interesting from the power consumption point of view. This is actually the motherboard that is inside. So inside you have 64 motherboard like this one, single socket, memories, the ASICs controlling what we call fabric, and each server is connected with the storage through the fabric, and server to server and server to storage through the fabric. And that's the secret of the performance of this machine. So it's actually a 3D interconnection. As I mentioned it to you, is an intellectual property we acquired from Micron. If you want to have any additional information, please don't hesitate to send me an email. I will be happy to answer to everything, including price. And thank you very much for your attention. If you have any question right now, I will be happy to answer. Otherwise, I stay here 1 hour maximum because there is NVIDIA after me and I don't want to. So I think I have to go.